Because k is fixed, the best average is exactly the best sum over any window of length k. That turns the problem into a classic fixed-size sliding window. We need the maximum average over all contiguous subarrays of length k. You are given an integer array nums consisting of n elements, and an integer k. Example 1 ends with answer 12.75000. Maximum average is 1256 plus 50/4 equals 51/4 equals 12.75. Example 2 ends with answer 5.00000. The important sizing limits are n equals nums.length, 1 lesser equal k lesser equal n lesser equal 105, and minus 104 lesser equal nums I lesser equal 104. This is the course sliding window update. A fixed size window never needs a full recomputation, because only one value enters and one value leads. Keep the current sum for the last k values. When the window moves right, add the new value and subtract the value that leads. So in practice, no need to recompute a full sum for every window. Each step removes one number and adds one number, and track the largest window sum seen so far. The example makes the key simplification obvious. Since every candidate window has the same size, comparing averages is the same as comparing sums. The best window is 12, minus 5, minus 6, 50 with sum 51, so its average is 12.75. So the walkthrough goes in order. First the window size never changes, then only the sum changes from step to step, and finally best average means best sum for this fixed k. For the deeper version, the important thing is not more code first. It is naming the invariant that makes every local move safe. The long version should pause on the invariant or the local rule that makes the solution reliable, not just on the final code. So in practice, name the rule that stays true while scanning, connect that rule to the pointer or state movement, and then the implementation feels natural. Initialize the first window sum once, then slide right by adding the new value and subtracting the outgoing value. In the code, focus on 2 checkpoints. Watch where the answer updates inside the loop, and notice which value is returned to finish the reasoning. Here is the full fixed window solution. The moving sum is the whole trick. In the code, focus on 2 checkpoints. Watch where the answer updates inside the loop, then notice which value is returned to finish the reasoning. This is linear time and constant space, which is exactly why sliding window is the right tool here. Each index joins and leaves the window at most once. So in practice, time complexity, O(n), extra space, O1, and this is the standard fixed size sliding window pattern. For more LeetCode practice, follow and subscribe to the channel. This is AI and human collaboration.